Hi chemistry class, I'm going to run through a titration example today. So I've got 40 mils of acidified sodium chlorate, NaClO4. This is the concentration, 0.9 moles per liter. We are titrating it with this hydrogen selenide. 66.1 mils is required to hit the end point. Let's find that concentration of H2SE. Okay, so the first step is to find the net redox. To do that, we need to write out what we have. So this guy is going to dissociate into these ions. It says it's acidified, so we have H+. All right, this is a weird looking thing. So I wanted to do an example with it. You'll find it in the data booklet, and it's actually just going to stay like this. Okay, so if you see H2SE, it's going to be on its own. I doubt you're going to see it again. And of course, we've got water. Okay, so here we go. I should mention a clue that this would stick together is that I asked for it, the concentration of it. But in any case, I don't think you're going to see it again, but I wanted to show you in case you do. Okay, looks good. We're ready to look for our SOA and our SRA. So let me get my crusty stained data booklet. I think we're going to find ClO4 near the top. It's with H+, which is okay because we have it. All right, so let me write out that half reaction for us. All right, now let's look for our SRA. It should be H2SE the way the question's set up. Let's see. I'm going up. There it is. Okay, so let me write out that half reaction. Okay, so here are our two half reactions. Next, we're going to have to multiply one of them to balance the electrons. So I got 8 here. I've got 2 here. That tells me I'm going to take this reaction. Oops, not multiply it by 2. I don't even think I can fix that. I've got to multiply it by 4. Okay, so sorry for the mess, but it's going to work. So our net, I got my ClO4. 8 of these guys. Now I got 4 of these guys. Okay, and that's all I really need. I just need the molar ratio here, but I'll continue with the net. Oh, and that's interesting. The H+ doesn't actually react. It's cool though, because it's needed for the half reaction. But then it comes back in the SRA half reaction, so it's kind of like a catalyst. That's really cool. I didn't expect that. Okay, here we go. I'm just going to leave it like this. So our next step, we do some stoich now. We're going to find how many moles of the known substance we have. So we've got 40 mils at this concentration. So we can find the number of moles of NaClO4. It's going to be concentration times volume. So 0.9 times 40 mils, which is 40 times 10 to the negative 3. Oops. Sorry, I was keeping that a secret. Okay. So that's going to be 3.6 times 10 to the negative 2 moles. Okay. That is also just the number of moles of ClO4. We discussed this in class a little bit. I don't think I'm going to give you a complicated dissociation, but if you need to see what happens, this in solution becomes sodium ions and the ClO4 ion, and it's 1-to-1. So how many moles of this stuff we have the same number of moles of that stuff. So this number is good. We want that. Next, we are going to find the number of moles of this stuff here. We're going to apply the molar ratio. So it's going to be this 3.6 times 10 to the negative 2 times the desired over the given. So this is what we know, the given, ClO4. Its coefficient will be 1. The desired here is 4. So I'm going to multiply this by 4 over 1. Okay, so I think I'm going to get 0.144. One day I'm going to get in trouble doing all this math in my head, but I don't think it's today. Okay, cool. Love it. Last step, I'm changing colors each step here. We find the concentration of H2SE. Okay, here's the number of moles. We divide by the volume we added in the titration. So 0.144. The volume, we added 66.1 mils. Definitely going to need a calculator here. So this is moles, this is liters. Okay, I'm getting questions about the 10 to the negative 3. That's what the M means. Milli means 10 to the negative 3. It doesn't matter what the unit is. So this is 66.1 times 10 to the negative 3 liters. You want liters because you want your concentration to be in moles per liter. So let's see what we get. Okay, I get 2.18. Okay, that looks good. I'm just going to ensure of that. I always like to see if my answer is reasonable. The other stuff had a concentration of 0.9. We added a bit more, about 50% more H2SE, but there's 4 times as much of it that react. Okay, so we should expect, 50% times 4. We should expect about double the concentration, and that's actually what we have. Okay, so that's pretty good. All right, I hope this helps. Good luck out there.